Let's look at problem 5.54, and it asks us to identify which element is oxidized and which is reduced. So remember that oxidized means it loses electrons and reduced means it gained electrons. So sometimes we can determine that just by looking at charges, and sometimes it's not as easy. So let's look at our criteria here. Anything that gains oxygen is oxidized and the other reactant is reduced. So if we look at 5.54a, we see sulfur dioxide reacting with oxygen to form sulfur trioxide. So sulfur gains an oxygen atom, that means it is oxidized, and the other reactant is reduced. Now that's not clear from any charges because just a covalent compound is formed. So this rule is really helpful when we're dealing with covalent compounds reacting with oxygen. Anytime an elemental metal reacts with an elemental nonmetal, the metal gets oxidized and the nonmetal gets reduced. So we see that in part B. We have sodium, which is an element because it just has one capital letter and it's a metal. And then chlorine is an element and it's nonmetal. So the metal gets oxidized or loses electrons and the nonmetal gets reduced or gains electrons. And they form an ionic compound that we can see from the charge which gets oxidized and which gets reduced. Sodium as an element has a charge of 0, same number of protons and electrons. But when it reacts with chlorine, it loses an electron to form a sodium with a +1 charge. So if it has a +1 charge, it's lost an electron. Chlorine on the left is an element, same number of protons and electrons, but when it reacts with sodium, it removes an electron and gains a negative charge. So chloride has a negative charge on the right-hand side, one more electron than it had before. So sodium gets oxidized, its charge becomes positive, and chloride becomes negative. Its charge becomes more negative. Or you can just look at this right here. Anytime a metal reacts with a nonmetal, the metal gets oxidized and the nonmetal gets reduced. Now, the more complicated one is this one. If a metal reacts with a cation to form a different metal and different cation, the original metal is oxidized or loses electrons, and the original cation is reduced or gains electrons. So we see C here, copper 2 chloride reacts with zinc to form zinc 2 chloride and copper. So we have a metal, zinc, reacting with a cation, copper +2. And we form a different element. Copper is our element that forms, and a different cation. Zinc +2 forms. Now chloride is along for the ride, so let's not let the chloride confuse anything. It's needed to counteract the positive charge of the cations, but it's not doing any chemistry. It's the same on both sides. So copper with a +2 goes to a copper with no charge. So its charge becomes more negative, it gets reduced. Okay, so the original cation is reduced. Copper 2 is our original cation. And the metal gets oxidized. So on the left-hand side, zinc has no charge. It's an element, same number of protons and electrons. And on the right-hand side, it has a +2 charge, which means it got oxidized. So whenever you see a metal cation reacting with another metal to form a different cation and a different metal, the original cation gets reduced and the original metal gets oxidized. Now this bottom one, you're not going to see an example like this on your test. This one's a little harder. It doesn't meet the criteria of any of these, and we're just going to look at the charges to figure out what happens. So sodium has a +1 charge on both sides. Doesn't do any redox chemistry, so we're going to ignore it from this point forward. Chloride on the left has a negative charge, and chlorine on the right has no charge. So chloride has gone from -1 to 0, so it's lost an electron. Chloride gets oxidized. If we look at fluorine, on the left it has no charge. It's an element, equal number of protons and electrons. And on the right, we see that it has a -1 charge, so it's gained an electron. So it gets reduced. So you won't see a problem like this, but hopefully that will help clear up how to answer the others. And then 5.56, it says balance each of these following redox reactions. We know they're redox because an element is either produced reacts, and in the last example, an element reacts and is produced. We know the redox, but it's not asking you to identify which substance gets reduced, which substance gets oxidized. All they're asking for you to do is balance. So just use your strategies for balancing chemical equations to balance these three equations.